my dear students. Welcome to India's biggest online platform, ME Educational Institutions. Let's start the session. Now we can solve some problems based on stress versus strain diagram. Read the question carefully. The graph below represents a typical stress strain diagram for a metal. Identify the point on the graph that is ultimate tensile strength of the material. So we already know this. So we can here PQRS. Here P is the elastic limit. Here it is a proportionality limit. Here elastic limit, and then yield point. This is the ultimate point. Answer will be R. Understood? So see here, this is the curve. Here P refers to elastic limit, Q refers to yield point, R refers to ultimate strength or ultimate point, and S refers to breaking stress or breaking point or breaking strength of the material. So this is the proportionality limit. This is the proportionality limit. Limit of proportionality. Proportionality limit. Understood? So up to here, stress is directly proportional to strain. Here up to this point, here I can say Young's modulus equal to E equal to tan theta equal to sigma by epsilon. So longitudinal stress by longitudinal strain. Sigma is directly proportional to strain. So sigma equals to E epsilon. So this is the Hooke's law. Hooke's law is valid up to proportionality limit. And here what is asked? The point R is ultimate point or ultimate strength or ultimate stress. The maximum stress that is recorded in tensile test. R is the ultimate point or ultimate stress, maximum stress that is recorded in tensile test. The answer to this question, they are asking the point R represents ultimate point or ultimate strength of the material. Read the question carefully. The diagram shows stress versus strain curve, the materials A and B. From the curves, we can infer that A is the ductile material, B is the brittle material. Understood? Which one is brittle, which one is ductile, they are asking. We already know that. Here it is the thing. Here sudden failure will occur. Curve A represents, this is ductile material. It is ductile material. It is having reasonable plastic deformation. Sudden failure will occur. Here sudden failure occurs in the brittle material. That failure is called brittle fracture or brittle failure. That is why brittle fracture and brittle failure observed in the brittle materials. Brittle materials are hard and brittle material. This is the brittle material. So B is brittle material, A is ductile material. A is ductile and B is brittle. That is the answer to this question. A is ductile material. I can say confidently, this is ductile material. Considerable plastic deformation. Ductile material. This is brittle material. This would be brittle material. Sudden failure will occur here. Now we can have a look on the stress strain graphs are shown in the figure. For two materials, A and B are shown in the figure. Young's modulus of A is greater than that of B. So what is given here? Young's modulus of A greater than Young's modulus of B is given. And one more thing, The Young's modulus for small strain. For small strain, very small strain. So stress by strain and the slope of the linear portion, slope. M equal to tan theta A is less than tan theta B. That is the reason. Okay, so which one of the following is correct, they are asking. So which one is correct? Okay, na? So I will tell you. So here that is given in the question. From this, slopes are given. Here theta A of course greater than the theta B. So from here tan theta A greater than tan theta B. Tan theta A greater than tan theta B. So we already know that Young's modulus of the material equal to slope of the stress versus strain diagram. Young's modulus equal to slope of the stress versus strain diagram, sigma by epsilon. This is the slope of the, here I can say that Young's modulus is the slope of stress versus strain diagram. Slope of stress versus strain diagram in the linear portion. So this part is clear, and from here we can say confidently YA greater than YB. So Young's modulus of material A is greater than the Young's modulus of material B. So which one is, here you can say this is the result. Here I can say that this and this. So now we can observe, now we can observe here Young's modulus of A is greater than, Young's modulus of A is greater than Young's modulus of B. This part is correct. This is correct. What about reason? Tell me, what about reason? Slope of A is less than tan theta A is less than tan theta B. This is not correct. Incorrect. Correct. Okay, na? So actually tan theta A is greater than tan theta B. That is why assertion is correct, but reason is incorrect. Understood, na? So this is correct. Reason is not correct. Understood, na? So this option C is correct option. Read the question carefully. The strain stress curves of three wires of different material are shown in the figure. P, Q and R. Elastic limits of the curves. Here which one is more elastic, they are asking. Elasticity of the wire P is maximum, elasticity of the wire Q is maximum, wire R is maximum, none of the above. Now we can try to solve this problem. What is given here? What is given? Curve P, stress was a curve P, curve Q and curve R. These curves makes an angle theta with the horizontal, that is positive direction of x-axis, theta P, theta Q, theta R. Now, which one has highest elastic property? That is very simple to calculate. We are already expert in this. Higher the Young's modulus, higher will be the elastic property. Lesser the elastic deformation, higher will be the elastic property of the material. Now, see here, it is very simple. Theta. Now we can see here, theta P greater than theta Q greater than theta R. theta r. So here tan theta p greater than tan theta q greater than tan theta r. So Young's modulus of the material P greater than Young's modulus of the material Q greater than Young's modulus of the material R. So R is having lowest material elastic property. And one more thing I want to tell you here, from here to here, what is the elastic deformation? From here to here, this is the elastic deformation. This would be the elastic deformation. Understood na? So here this part, these three are elastic materials. Understood? Perfect elastic because slope is constant. All are behaving linear. Okay na? So I can say from here to here, this you can draw a dotted lines, we can draw, that is better. Now see here, now we can see elastic deformation. This would be elastic deformation. All three are perfect elastic materials because slope is constant. Okay, so we can draw dotted lines up to here. This would be dotted lines. From here, this would be dotted lines. So RL straight away you can say P is having maximum, R is having minimum elastic property. Okay. So here it is what? Now I can say from here to here elastic deformation. This would be elastic deformation like this. So here I can confidently say that. So this is the elastic deformation of material P. Elastic deformation of material P. Elastic deformation of material Q. Elastic deformation of material Q. Elastic deformation of material R. So here from this we can say elastic deformation of material P will be lesser. Elastic deformation of material Q, elastic deformation of material R. So you can easily write this elastic deformation is also called as delta LP less than delta LQ less than delta LR. So in general, delta L equals to in general, delta L equals to FL by, this is FL by AY. Y is the Young's modulus. Delta L is inversely related with Y. So inversely related with Y. So from that you can easily write this expression. Higher the Young's modulus, lesser will be the elastic deformation. Lesser the elastic deformation, higher will be the elastic property of the material. You can easily write lesser the elastic deformation. Lesser the elastic deformation. Lesser the elastic deformation, higher will be the elastic property of the material. elasticity of the material, elasticity of the material, because lesser the deformation, it can easily regain back to its original position. Higher the deformation, it is not that much easy as lesser deformation case. So it is lesser elastic properties minimum, elastic properties minimum, elastic property of the material R is minimum. Okay, P is having highest elastic property of the material. So material P is having highest elasticity or elastic property. Now we can see the options. Elasticity of wire P is maximum, elasticity of wire Q is maximum, tensile strength of R is maximum, none of the above. Here elasticity of the wire P is maximum. Okay, so because higher the Young's modulus, higher will be the elastic property. Lesser the elastic deformation, higher will be the elastic property. Tensile strength of the R is not maximum, tensile strength of the P is maximum. Okay, so that is the thing. You can project it. You can easily say, you can project like this. Which one is having more strength, tensile strength? P is maximum. So elasticity of wire P is maximum. Now we can have a look on the another problem. The diagram below shows the change in length delta L per unit length. Actually, they have given in this question delta L only mentioned. So if it is delta L on x-axis, they will give delta L per unit length. Thin uniform wire for single material they have given, for single material at different temperatures. So caused by application of stress sigma at two different temperatures. Material is same. So I can say this is case 1. This is case 1. This is case 2. Case 2. Two different cases, and that means at two different temperatures they conducted experiment on same material. The variation show suggests that they are asking T1 and T2 relation, in which case temperature is higher. So we need to decide that. See here, it is very simple. In which case that part is as the temperature increases, strength of the material decreases and ductility of the material increases. As temperature increases, strength of the material decreases, ductility of the material increases. It is very simple. Here ductility of the material increases, strength of the material decreases. Strength of the material decreases, in which case strength is higher. Here strength of the material, I can say that strength of the material, here I can say that this would be case 1. This would be case 2. Okay, strength of the material, strength, I can say that strength of the material in case 2. Case 2 higher than the strength of the material, strength of the material in case 1. Understood na? In case 1. So strength is higher and temperature will be lesser. Understood na? Temperature increases, then strength will decreases. So it is very simple. Temperature of the material, temperature increases, then strength of the material, strength of the material decreases. Strength of the material decreases. So that means what? Temperature is inversely related with strength. Okay, inversely. Actually, temperature, no? Strength is inversely related with temperature. Okay, so higher the strength, then lesser will be the temperature. That means T2 less than T1. Okay, so this is at higher temperature. That is why strength is decreasing. This is conducted at higher temperature. That is why strength is decreasing. Ductility increases. Higher temperature. This is conducted at lower temperature. That is why strength is higher. Okay, temperature T1 is higher. Understood na? So which one is having more strength? That means you can easily say which is more stronger. Like this you can decide. For same deformation, for same amount of deformation, in which case stresses induced is higher. Second case, stress induced is higher. So I can say that here strength is higher. This would be sigma 1. Then it is able to withstand. Understood na? Then it is more stronger and it is having more strength. You can easily judge. In case 2, strength of the material is higher than the strength of the material in case 1. Higher the strength, that means you are conducted an experiment, tensile test at lower temperature. Understood na? Temperature increases, strength of the component decreases. Okay, so that is the case and answer to this question. So you have taken same material but at different temperatures. Among these two, which one is higher temperature, which one is lower temperature, you can easily decide. If you conduct an experiment at lower temperature, strength will be higher. If you conduct an experiment at higher temperature, strength of the material is less. Understood na? In that manner, you can decide the relation between T1 and T2, which one is higher. So I can confidently say that T1 is greater than T2. That is the answer to this question. Are you following now? This part is clear. Higher the strength, and at that when you will get more strength at lower temperature. Okay na? So here I can write higher the strength. Here strength, here lower strength. Okay na? Strength will be lower. At higher temperature, strength is less. Yeah, what is the answer to this question? T1 greater than T2. Yeah, this is all about some problems related to stress versus strain diagram. This is all about some content related to stress versus strain diagram in the intermediate level. Next class, we will be focusing on some problems based on stress and strain. Please do subscribe METube Intel Physics YouTube channel. Thank you. We can meet in the next class. Thank you. Please do subscribe METube Intel Physics YouTube channel. Thank you. We can meet in the next class. Thank you.